I don't have Netflix either. All right. Okay.
16.
Question number 16. All right. Correct page. So we're here on pages 61 and 62. So page 62, number 16. -3 minus parentheses 2 plus parentheses -2 minus parentheses -3 parentheses -2. Now, what do we have to do first? What do we do first here?
We are going to do -3 times -2.
Yes, we'll do our multiplication first. -3 times -2, what do we get?
+6.
+6, all right. All right, now what do we do?
Do -3 plus -2.
So before we do that, what I think we should do is before we start adding, is we should get rid of any subtraction. I think this will make our lives easier.
Any subtraction?
Yeah, so let's eliminate the subtraction. So instead of writing -2, what are we going to write?
Plus -2.
Plus -2. And here, instead of writing -6, we'll write
Plus -6.
plus -6. All right, so we've got negative. Anyone?
1 second.
Well, is it going to be positive or negative?
-3
3 plus 2 is?
5
Plus 2 is?
7
Plus 6 is?
13.
13, -13. Okay, so make sure, two things here. Notice that these parentheses here around the 2 and the -2, we can even just ignore those. Those aren't necessary there. They don't actually convey any useful information to us.
Okay, so let me get this straight. If there's nothing in between them, then in between the parentheses, then it's multiplication.
Right, like this, yeah. -3 times -2, and it's parentheses. Hey, it's multiplication. Yes. Yep. Any others anyone wants to go over?
Number 17.
17. All right, similar deal. 17. -5, parentheses, -3 minus 2, close parenthesis, plus, parentheses, -2 minus, -3 minus 4. All right, so what do we do first?
-3 plus -2.
-3 plus -2, okay.
And -3 plus -4.
All right. We could also convert this to adding a negative. This one.
Oh yeah.
Okay, now what do we do? So we've gotten rid of subtraction, which is great because I hate subtraction. What next? Order of operations tells me to do what first? Parentheses. So what do I do inside my parentheses?
You add -3 and -2.
And I get
You get -5.
-5. Okay.
And I would just put parentheses between -5 and -5 because
And then what do we do over here?
you add -3, -4, -7.
-7.
Sure, there's a negative on the parentheses.
Right. So notice how I copied everything directly from up here. The only difference is that instead of writing -3 plus -2 inside the parentheses, I wrote -5. And instead of writing -3 plus -4 inside these parentheses, I wrote -7. But all the rest of my negative signs stayed there. Now what do? After parentheses comes what?
25.
Yeah, exponents and the multiplication. So there's no exponent, so I'll multiply. -5 times -5 gives me?
25.
All right. Do I do anything here yet?
Mm-hmm.
What do?
add it to the 25.
What?
Add it.
No, we're not doing subtraction yet. We're still doing, we want to go one step at a time. Are we done multiplying?
Mm-hmm.
No, we're not. In one sense. Okay, so plus negative 2 plus, let's simplify these negative signs. Remember, negative signs, one way to think of them is times negative 1.
Plus 7.
So I recommend that you simplify your negative signs when you do your multiplication, because that's really what it is. What this means here is negative 7 times negative 1. So this becomes what?
7.
Plus 7, right. All right, now we've got 25 plus negative 2 plus 7. What do we get? 30.
Yeah.
25 plus 7 is 32, plus negative 2 brings us down to 30. Okay, so for that one, make sure you're going in order, doing your parentheses first, and also keep track of these negative signs, especially this one here, negative 7, that's going to cancel out to become positive 7.
Number 20.
Okay, let me just pop over this window. Yes.
At a certain time today.
Depends how quickly, fingers before you guys go, my guess is end of second or beginning of third. For you guys.
So it's not gonna be.
I doubt it. Number 20. Okay. Yes, number 20 is a good one. Let's negative 6 over negative 10.
Mm-hmm.
Plus, parenthesis, negative 3, parenthesis, negative 2, close parentheses. Plus, 3 pipe, negative 4 minus 2 pipe. All right. Order of operations tells me to do what first?
Parentheses.
Parentheses. What do I have in parentheses here to do?
Negative 3 times negative 2 and negative 4 plus negative.
So be careful because these two, this is multiplication. There's nothing happening inside these parentheses. The multiplication of negative 3 and negative 2 happens between those parentheses, not inside them. We want to do the stuff inside the parentheses first. And as you correctly identified, the pipes count as parentheses. So first thing we do is negative 4 minus 2 or negative 4 minus negative 2. Sorry, plus negative 2. So what do we get there?
Negative 6.
Okay, negative 6. All right. The rest of this is still the same. Okay, are there any exponents to do?
No.
All right, so we can move on to multiplication. And the third step after exponents comes what? Multiplication and division. Okay, so we can start on the left here. What do we get?
3 over 5.
3 over 5. Okay, multiplication plus?
Plus 6.
6 plus what?
Plus 3. Plus 6. Oh, that's multiplication right there.
This is multiplication.
Plus
So
negative 18.
be careful. This
That
is,
turns into positive 18.
right, so positive 18. Because the pipes tell us make this negative 6 positive, and then we're going to multiply by 13. So the negative 6 becomes positive 6. Then we multiply by 3, we get 18. All right, so we got 3/5 plus 6 plus 18. Add those together, what do we get? Well, what's the whole part going to be? Add together the whole numbers, what do we get? Anyone?
After adding the whole number?
Add the whole numbers, what is that going to give us?
7.
6 plus 18?
Yeah.
20.
6 plus 18.
Tell you what.
I didn't do 6 plus 18.
Why?
Oh, right, because I messed that up.
Yeah, 24 and 3/5. We'll end up with a mixed number. 24 and 3/5.
Don't give the change the whole number.
Say that again?
Don't give the change the whole number.
Change what whole number?
That one, because it's 9 years 5.
So when we have a couple whole numbers and then a single fraction, we can just write them like this. We don't need to change it into an improper fraction. We can leave our answer as a mixed number. That's okay. So remember, we have 3/5 plus 6 plus 18, or 3/5 plus 24.
In order for that to work, we have to make like 6, 4, 5. You get to do that also.
No, because these are whole numbers, and we're writing it as a mixed number. A mixed number means that there's a whole part and a fraction part. What 24 3/5 means is it means 24 plus 3/5. That's what a mixed number means. Right? Because you've got 24 whole pizzas, and then I'm giving you another 3/5 of the pizza. That's what it means to have 24 and 3/5 pizzas. So when you've got something like this, where you've got 6 and 18, which are whole numbers, we can add those separately, we can add our fractions separately, and then write it as a mixed number. It's only when we're adding fractions to other fractions that we need to make everything have the same denominator. Okay, but that's why it's called a mixed number, is because these are not the same kind of thing, the two parts of it. 24, that's 24 over 1, and then 3/5, that's a fraction with a denominator of 5. All right, other ones. I don't want to go over another one of those problems. Different type of problem. Any others you want to go over? Going once. Anybody at home want to request any? Going twice. All right, so moving on to lesson 14, page 63. Open up your textbooks to page 63, please. This is a core concept for the whole year. It's pretty intuitive, but let's make sure that we... Whoa, that was not an E. All right, algebraic expressions. Algebra is the name of this class, Algebra 1. Anyone know what algebra means? What language it comes from? It's a type of math.
Arabic.
It comes from Arabic, yes, and it means?
I don't know, complex something.
Nope.
Can't see.
Say that again?
Can't see it.
Algebra from Arabic means the unknown.
This can be on our test.
This particular piece of information? No. But it's good to know. The unknown. Algebra is the branch of math that deals with unknown quantities. How can we do math when there are numbers that we don't know what they are? We don't know what they are yet.
You can't.
We can. We invented this whole branch of math to do it, called algebra. It's actually really amazing. It's an incredibly powerful tool. The unknown. The thing that, the sort of defining characteristic of algebra are what we call variables, or sometimes referred to as unknowns. But I'll call them variables. And these are letters used to represent numbers, or I should say unknown.
I think this sports jacket off.
Yeah, it's pretty warm in here. Letters used to represent unknown numbers. We call them variables. Why? Because we can use the letter to represent any number. There are certain letters we commonly use. The most common one is X. N is commonly used. Y, Z, Q. Okay, but it could be any letter. And it stands for a number. And we could make these letters represent any number we want to, depending on what we're doing. That's why they're called variables, because what number they're representing varies. We say that variables have a value. Their value is the number that they represent, or that they stand in for. A variable is a letter that represents a number, an unknown number, and the number that it represents, we call its value. In any given problem, the same variable always has the same value. Same value. If you use x to represent a number, you say x represents 5. The value of x is 5. For the whole problem, every single time that you use x, it has to mean 5. If you change what it means, then it's useless. It's meaningless. If you want to represent some other unknown number, you can use a different letter. But every time that you use x in the same problem, it has to have the same value. Because by giving that value the same letter, we're saying that they're equal to each other. So for example, when we have an expression like this, and when I say expression, this is not an equation, because there's no equal sign. It's an expression, it's a mathematical thing. We call this an algebraic expression because one of the things in it is what? What's one of the things in that expression there? 4 plus x. 4 is one of the things.
X.
And x is another one of these things. X is a what? What do we call x?
Variable.
A variable. Okay. 4 plus x, what's the value? What does 4 plus x equal? It could be anything because we don't know what x is. The value is 5, then what's 4 plus x?
9.
Right? If x equals 5, then 4 plus x equals 9. All that x is doing there is standing in for 5. How do we know it stands in for 5? I just told you, x equals 5. If x equals negative 3, what's 4 plus x?
7.
Oh.
1. If x equals negative 3,
I had a negative.
yeah, 4 plus x, 4 plus negative 3 is equal to 1. What if x is equal to 2/3? What's 4 plus x equal to then? 4 and 2/3. Just something like this, 4 plus x, without any further information, we don't know what the value of that is because we don't know what x is. Now, if I tell you what x is, then you can figure out what its value is. But just like that, just an algebraic expression by itself, we can't tell the value unless we pick a value for it. All right. What next? We could also write something different. What about 4x? What does that mean, 4x?
Multiplication.
4 times x, right. Okay. 4 times x. And then, so we could say, if x equals 5, what's 4x going to be? 20. If x is negative 3, what's 4x going to be?
Negative 12.
Negative 12. If x equals 2/3, what is 4x going to be?
What is that? 8. Yeah.
What was that? Not 12 over 2.
12 over 8. 14. I mean, 8 over 12.
If x equals 2/3, what is 4x going to be?
2. Yeah, 2 over 12. 3 over 8.
Wait, if x equals 2/3, then 4x equals 4 times 2/3, right? Yes, everyone following so far?
I said 8 over 8.
Okay, so to multiply this fraction, this whole number, we gotta write as 4 over 1 times 2 over 3. Then we just multiply across the top and across the bottom, we get 8/3, or if you want to write it as a mixed number, 2 and 2/3. Either one. All that I'm doing is I'm plugging in different values for x. Because it's a variable, it can change.
Alright, question.
Yep.
How do you get to the thirds? How do you do
How did I get 2 and 2 from this? You see how I got 8 thirds? Okay, so 8 thirds, I have 8 slices of pizza. Each one of those slices makes up a third of a piece. So the first 3 slices give me 1 whole pizza. The next 3 slices give me another whole pizza. That's 1, 2, 3, 4, 5, 6 slices. And then I have 2 more slices left. That's really ugly. And then I've got 2/3 of the pizza still.
Well, I mean, like, how?
How did I calculate it? So because 3 goes into 8, how many times?
Once. Not twice.
Twice, and then how many are left over? It goes into 8 twice. 2 times 3 is what? 6. So
Two left.
there are 2 left over, right? So I've got 2 whole pizzas, and then of the remaining there are 2/3 left over. So I've got 8 thirds. I'm going to be able to make 2 whole pizzas and have 2/3 left over. So that's the way to do it. It's like the opposite of making a mixed number. Ask yourself, how many times does the denominator go in there? And then whatever's left over will become a fraction.
If x equals 1,
Yep.
how is x negative 1?
What?
Like, x equals 1.
If x equals 1, okay, then what's 4x?
No, if x equals, literally, the problem, x equals 1.
Where?
It's
Sorry.
not up there, I'm just
Okay,
asking.
so x equals 1. Okay.
So it can be 1 and negative 1?
No, because we already said that x equals 1. If we put an equal sign in there, we have an equation, then we're not going to have options. Because by saying x equals 1, we know that x is equal to
1.
1, right? If we say that 4 plus x equals 1, then what does x have to be?
Negative 3.
It's got to be negative 3. So it's only when we don't have an equal sign where we can't figure out the value, where we're going to have to be flexible and see what they tell us. If there's an equal sign in there, where you have a variable on one side and not on the other side, that's when we're not going to have options. But we're going to see that. All right. Okay, we can have multiple different variables in the same equation. Man, we're running out of time. That's okay. This is a good lesson to spend time on. So let's actually, I'm going to change strategy. So turn to page 64. Let's take a look at some of these examples here. Let's, in fact, just start with example 14.1 and work our way through these. So 14.1 there, they say find the value of xmp. Now, because this isn't an equation and we've got variables in it, they have to tell us what they are. If what? What do they tell us? If what? X equals 4, m equals 5, and p equals 2. All that we're going to do is every time we see x, we'll plug in 4. Every time we see m, we'll replace with 5. And every time we see p, we'll replace with 2. So x and p, we can rewrite it as what? 4 times 5 times 2. X, we replace with 4. M, we replace with 5. P, we replace with 2. 4 times 5 times 2 gives us?
40.
40. Whoa.
You said 4 times 5.
4 times 5 times 2.
4 times 5 times 2.
That's what I said 20.
Oh, I'm sorry. Yeah, 4 times 5 times 2, 20. 40. Sorry about that. I do misspeak sometimes. All right, let's look at the next one. So, evaluate is another way of saying find the value of. They say evaluate 4yz minus 5 if y equals what? Let's say y equals. And what's in the book? This is example 14.2. Y equals 2 and Z equals 10. All right, so what do we do? How do we rewrite this?
4 times 2 times 10,
4 times 2 times 10.
80.
Hold on. Let's rewrite the whole thing first. Anytime that you're plugging in values for variables, rewrite the whole thing and then solve it. So 4yz minus 5 becomes 4 times 2 times 10.
8.
No, don't multiply this together yet. Rewrite the whole thing, the whole expression, with the variables in there. You're forgetting something. 4yz minus 5 becomes 4 times 2 times 10 minus 5. Yes, rewrite the whole thing first, then calculate the value of it. Notice all that I did between this and this is that I replaced y with 2 and z with 10. That should be your first step. You can also write it like this. Okay, that's actually not a bad habit to get into, to replace your, when you replace variables, to put parentheses around the values. And we'll see later, we'll see actually in just a little bit why that's a good practice. So 4 times 2 times 10 minus 5, what do we do first? What do we do first?
10 times 10 times 2.
10 times 2 times 4 gives us
80.
minus 5 is 75. Yes. So just make sure you do multiplication first, followed by subtraction. All right, example 3. Example 3, y minus z if y equals what? What are they telling us?
Negative 2.
Negative 2 and z equals?
Positive 6.
Nope. What does z equal?
There's negative z positive 6.
What? Okay, what do they tell us? Evaluate y minus z if y equals negative 2 and z equals?
Negative 6.
Negative 6. All right, so,
I was reading something else.
yeah, you're reading the next line down, the explanation of what we do. All right, so here, y is negative 2, z is negative 6. I really recommend with these kind of problems, write this information down and you've got it there in front of you. So, what are we going to do at this point? We replace y with what?
Just multiply and take 2 times.
No.
Negative 2.
We replace y with what?
Negative 2.
Negative 2, and we replace z with
Minus negative 6.
negative 6. Now, so we get negative 2 minus negative 6. Here, when the values of your variables are negative, is where I really recommend that you just stick parentheses around them when you write them in. So replace y with negative 2 inside parentheses. Replace z with negative 6 inside parentheses. The parentheses don't do anything there. They just help you keep track of where things are. Negative signs in particular. This is really, really important not to lose track of negative signs. So here, negative 2 minus negative 6, how do we rewrite that? Minus negative 6 we can rewrite as?
Plus negative 6.
Not plus negative 6. I will rewrite minus negative 6.
Plus positive 6.
Right, plus 6. Negative 2 plus 6. These two negative signs will cancel out. We get negative 2 plus 6. What does it equal?
Equals 4.
4. Okay. When the value of your variable is negative, like here, y is negative 2, z is negative 6, I really, really strongly recommend that you write them inside parentheses when you plug in those values. Let's do number 4. We got some more negative values here. All right, now they tell us negative a minus b minus ab if what? If a equals?
A equals negative 3.
And b equals?
Negative 4.
Negative 4. Now, when we rewrite this plugging in these values, what do we want to be careful to do?
Alright, this is
Put parentheses around them. So what are we going to write here instead of negative a?
negative 3.
No.
Oh no, negative, and then parentheses, negative 3.
Yes.
Can't you just write 3 like you do that all
For this one, which is really simple, no. But is this a good habit to get in so you don't mess yourself up later when we get more complicated? Yes. So remember, negative a means negative negative 3. It is going to become 3. Well, let's take one step at a time. Minus what?
Minus negative 3.
Minus negative 4. Minus what?
Negative 3 times negative 3 times negative 4.
Times negative 4. Notice, all that I've done between here and here is just replace each of my variables with the value that they gave us inside parentheses. So a became negative 3 in parentheses. B became negative 4 in parentheses. A became negative 3 in parentheses. B became negative 4 in parentheses. Notice both a's are equal to negative 3. Both b's are equal to negative 4. At this point, I can now apply my order of operations. So what's going to happen first? Multiplication. There's no parentheses to do anything inside of. There's no exponent. It's multiplication. So what am I going to get when I do multiplication?
3 plus 4.
Yeah, so negative negative 3, we can do that with multiplication, becomes positive 3.
3 plus 4.
Yeah, we can do again here, right, that's negative negative 4, so that becomes plus 4. And then, what do we get over here?
Plus negative 20.
Negative 3 times 4 is, yeah, 12.
Twelve.
Right, so negative 3 times negative 4 gives us positive 12, but then we're subtracting it, so plus negative 12.
Mm-hmm.
Okay? Make sure you're canceling out these negative signs correctly. That's why it's really important to use these parentheses here so you can keep track of your negative signs. So what do we get? 3 plus 4 plus negative 12?
Negative 5.
Negative 5. There we go. All right, one last one. Then I'm going to let you guys go. There won't be any homework tonight. Because I'm such a nice guy.
Yay.
Okay, example 5. Negative x minus parenthesis negative a plus b close parenthesis. If what? If x equals
2.
x equals 2, a equals,
Negative 4.
and b equals. All right. Let's rewrite it. What am I going to write? Negative
Negative 2.
2. I could write parentheses there, but I don't have to. Minus parenthesis. Yeah, positive 4. Negative negative 4 is going to give us positive 4. Notice, I'll use square brackets here just to keep things straight. Plus negative 6. Replace x with 2, replace a with negative 4, and replace b with negative 6. The negatives should really go inside parentheses. Here I'm using square brackets just because I've already got parentheses there so I can keep them straight. All right, so what do I do first?
The thing,
First step, order of operations.
4 plus negative 6.
4 plus negative 6 inside the parentheses will give us what? 4 plus negative 6 will give us negative 2 inside the parentheses here. All right, negative 2 minus negative 2
Negative 2 plus 2.
is negative 2 plus 2 is
0.
0. Please keep in mind with these. Copy things out accurately, especially when the values are negatives. Put parentheses around them when you're plugging them in. Go one step at a time, do your order of operations correctly. I really recommend, especially as we go through the year, these get more complicated, that your first step, you don't do any math. You just replace the variables with their values. Then you go through one step at a time, being careful with your negative signs, and do order of operations. No homework tonight. Test corrections are due Wednesday. Our next test will probably be Friday. And that'll cover up through lesson 12. What was that? Friday?
Oh, that one. Okay.
Were you here yesterday?
No.
Okay, so then I guess you can get back in. Goodbye.